Okay, so with this, let me again welcome you to this session on automotive innovations for sustainable and safe mobility. So this particular track was conceptualized when we started deliberating about VLSI D2023 a year back, and we wanted to do some industry forum, and there was a very clear-cut, loud, I would say echo everyone saying that we should do one session focused on automotive because that has, changed everyone's lives, revolutionized everything, and thanks to the chip shortage, which made us important all across the globe. So for this particular session, when we wanted to get started, we were looking for a leader who can, help us out to conceptualize the whole this track for automotive for 3 hours. And then we started, looking who across, all across the globe, who could be that right leader who can run it, this particular session and help us out to, formulate it in a, meaningful way. And everyone then again echoed that, Mr. Sanjay Gupta, who's amongst us, would be the best person who can help us out to mentor, guide, and conceptualize this whole session. So let me welcome and request Mr. Sanjay Gupta, who is President and CEO of Minda Corporation, to come on the stage and give us a brief overview of this session. Sanjay.
Thank you, Preet. It's a great pleasure to be here. I have a special affinity with Hyderabad for multiple reasons, but I did my 2-year stint in ISB. And this was almost my second home for a long time. So special happiness to be here. In addition to that, in my prior organization until last month, I was part of NXP. And we had a very vibrant, thriving design center in Hyderabad, in addition to Noida, Bangalore, and Pune. So there are multiple reasons I'm very happy to be here. Now, coming back to the VLSI conference and the significance that this conference holds, it goes back maybe 22 years back when the first time I attended that as a fresh analog design engineer and realized that the power of networking, the power of listening to intelligent, talented people from both your organization and across the organization, it opens up your vision, and from a tunnel vision you start seeing the big picture. And that was a turning point for me, where I started appreciating what a value creation it is when you go out of your comfort zone and subject matter that you are responsible for, and look into what great things are happening around the world. And that is the true power of inspiration, power for you to go out of your unknown areas into the uncharted territories and start thinking about possibilities, because innovation is all about thinking about possibilities and make them real. We talked about the importance of automotive, right? So I think we all know that automotive industry is the growth driver for electronics, and when we were comparing semiconductors growth in last many years, automotive driven growth in semiconductors was one of the largest, both in terms of the dollar content that goes, say, per vehicle, whether it is a two-wheeler or four-wheeler, as well as in the number of vehicles that it is going. So effectively, automotive is the growth driver for all of us. And I personally wanted to see the other side of the table within automotive. Hence, I did this movement to my new organization, Spark Minda, because we are now leveraging the semiconductors and electronics and building electronic systems for electric vehicles, for driverless cars, for infotainment clusters, e-cockpit, etc. But everything finally goes to electronics and semiconductors. I'm so happy to see that people talk about across the world, whether it is FIIs or whether it is the Morgan Stanleys and the big consulting companies, that the entire growth that we have seen as a country in last 70 years, we are going to see threefold growth in next 10 years. From a $3 trillion economy, within a decade we might be a $10 trillion economy. So imagine, not only it will be 7x faster, it will be 3 times bigger. So effectively, more than 25 times of acceleration we all are going to see. And one of the beauty of human mind is, it cannot think exponential, it can think linear. So we all will see 10 years from now that the world will be very different, and Indian companies will be helping in this 10 trillion GDP, which will be coming from semiconductors and electronics. And this message is to all aspirants who are building their career that this is the field to be in. Innovation is our lifeline. So stay hungry and stay foolish, as one of the famous leaders used to say. And rest is going to be very natural for all of us. So looking forward to this session. We have multiple keynotes from 3 industry leaders, Ravi from ST, Venkata from Signi, and Amar from NXP. And then we have a panel discussion, again, with the 4 industry folks, where we are going to deliberate upon the possibilities of making this dream into a reality within next 10 years and make India great and make automotive industry the leader for this growth driver. So with that, once again, thank you to everyone for conceiving and putting this panel in place. And thank you, Preet, for driving it from the front. Back to you, and looking forward for the same. Thank you.
Okay, so I would request the AV team to get the slides on for the first presenter. So what a great start is going to be. Amongst us is Mr. Ravi Kodli Nagaraja. So Ravi is a senior director and site head for ST ADG India. He heads the automotive group, drives SoCs, IP development for microcontrollers, infotainment, radar, and ADAS. Prior to ST, he spent several years with Qualcomm, Intel, Infineon, Agilent, OKI in the space of SoCs, IP design, and systems. He's with this industry for 2.5 decades. His bio goes along with all the big achievements he has done all these last 25 years. And Ravi would be talking about the new automotive trends and market demands. So with this, let me take again this honor and privilege to welcome Ravi on the stage. Ravi.
Good afternoon, everyone. I know it was a very good lunch, and probably half of you are sleepy. So I will try to keep it not so boring, and questions are welcome. I will take about 20 minutes to go through my slides, and the last 10 minutes, I think you can ask some questions. Let's keep it interactive. I personally am also a fairly new entrant into the automotive market. Been in the automotive space now for about 3 years. Prior to this, I've spent several years with hardcore mobile solutions, modems and things like that. So what a journey it has been over the last 3 years. And thank you, Sanjay, for that very kind foreword. Automotive is here to stay. Automotive, semicon is here to stay. And I think India can really play a very important role to make automotive SOCs and automotive semicon and the ecosystem a very vibrant one. So with that, let's get started. Just to get everyone on the same page, a very quick history lesson, not to bore you, but to keep you awake. 1908, the very first automotive rolled out of the assembly lines. This was the Ford T model, and it was a mechanical beast. There were no electronics, there were no electrical systems in that. Few years down the line, the very first electrical systems came into play. Starter for the car, motor starter for the car, and lighting systems for the electrical light bulb. Then the next big breakthrough came in 1968 when Bosch invented and designed the very first electronic fuel injection system. This fuel injection system was driven by a ECU, which powered a Volkswagen car. And that was a game changer. From then on, fast forwarding to early 1980s and into 2000s, we have seen a huge influx of ECUs, electronics for all facets of the car. Today, we are in 2023. We've already seen significant proliferation of sensors, specialized ECUs, specialized systems in the car, which are really kicking up the semicon content, kicking up the BOM of semiconductors in any given car. We are already seeing significant EVs on the road. India, which always felt that we will not have enough EVs, today is talking about a few million EVs on the road. Connected cars, quite common. We are all driving connected cars. And we are already starting to see significant inroad of autonomous cars in India, and definitely a lot more in the West. As you can see on the left side of the chart, it took close to about 15 years, 15 to 17 years, for the semicon content in a car to grow by 1.5x. Whereas from that point to now, it has more than doubled. It has been close to 2.5x in a mere span of 4 years. And I think this is going to go up in a logarithmic scale. The growth of semicon content is going to be massive, so difficult that I think all the companies which are in the automotive SOC, automotive semicon, are going to have a tough time to fulfill their order books. Do you know what are the three key things, key disruptors which are driving this change? Any guesses? Innovation, innovation, and innovation. Engineers cannot be kept away from innovation. Consumers want innovation. Customers want innovative products. Electrified vehicles, second big game changer. The semicon content in an electric car versus an ICE car, internal combustion engine car, close to 3x. Digital and connected cars, once again, massively driving the silicon pervasion into a car. Keeping the positive trends which are driving the car industry and the semicon industry, I want to briefly talk about the car volumes. China, India are going to be the new key growth drivers for the automotive semiconductor industry. Legacy automotives will continue to see growth of semicon. For example, take simple Honda City. Old generation car, newer avatars, newer generations coming every 2 years. The amount of comfort, the amount of safety, the amount of infotainment significantly increased over the last few years. How is this possible? Only through semiconductors. We are all asking for extended features, better driving experience, better comfort, safety, and new car functions. Once again, significantly driving up the semicon content. Disruptive trends, we talked about it, electrification and digital electronics in the car, ADAS included, once again driving the amount of semicon content. And most importantly, over the last few years, we've always been wanting safer, greener, lower carbon footprint cars. So there's been legislative and functional safety aspects which are into play over here. All these are key positive drivers for the automotive semicon. Some very practical examples. I'm just taking a very simple example of ESC, Electronic Stability Control. I think you all know about it. Something which keeps your car stable, something which keeps your car from rolling over, something which ensures that there is ample traction between your car tires and the road below when you're taking sharp turns, when you're on snow, or when you're in desert conditions. A very simple, but yet very essential piece of hardware in a car. There are thousands and thousands of such components. Take a look at the example. 2018, an ESC typically would have one ECU, 3 ICs. Single core MCU, 120 megahertz, 1 MB. Fast forward to today, 2022, the same functionality, dual core MCU, 300 megahertz, and 4 to 8 MB. Proliferating into 9 different IC chips. Straightforward, a 3x increase in the silicon content. Next generation EC, already in the systems, already in the cars, we are seeing up to 15 IPs, 15 ICs. Multiple cores, 400 megahertz, significant larger memory. This is the most simple example which I can pick up. If I take examples which are larger, more complex, the silicon content quadruples, becomes even potentially 5 to 10 times. Imagine what this is going to do to the semicon content in a car as we continue in this logarithmic scale. Let's talk for a minute on BOMs. I know many of you probably have a lot better idea than what I'm presenting today, but an average internal combustion engine car, about $600 worth of semicon in it. Mild hybrid, full hybrid goes up to about $800. An EV car, on the other hand, is close to about $1,500. Add to this autonomy. You know, right? What are the different levels of autonomy? It starts from L2 into L5. L2 is the most basic, minimalistic autonomous car. L5 is a fully autonomous car. We're not even talking about L5. We're talking about L2 through L4. So L2 is about $350, $400. L4, we in the industry have not been able to calculate what the BOM will be. Sky is the limit. I believe it could be anywhere from 2.5 times to 5 times. And I think an L5 or an L3 car is not too far away. In India, we are already having L2, L3 capable cars on the street today. So these are some very, very essential trends which will change this ecosystem drastically. And as some of my colleagues here were speaking earlier, I think also in some of the previous engagements, automotive semicon is here to stay, is here to grow. And I think we in India can really make a massive, massive engagement and contribution to this space. Briefly talking about the total available market. Electrification, 21 to 2025, we see a growth of 32%. And by 2025, electrification will be contributing to $18 billion. Software-defined vehicles, the new big thing. $19 billion by 2025, growth of close to 20%. And the overall automotive TAM stands at a staggering $82.7 billion. Imagine what this does to our ecosystem, what this does to the overall development scales. And by 2030, most of the big car manufacturers have already announced that they will go full electric. By 2030, the big ones in Europe are going to go full electric, and you can imagine how the electrification charts will look like then. Continuing on this trend, there are also some very interesting changes which are happening, which are already in production. So we see high-end microcontrollers, production ramping up through many of the companies. ST is one of the key companies out here. 2023, we see high-end microcontrollers performing very well. Mid to high-end microprocessors to cater to the various car zones. Ramp up expected in 2026. High-end computing platforms and very high-end vision processing and AI engines. Volume production by 2027. All this is happening. Architecture has been done. Designs are being worked upon. Production is going to be ramping up. These are some of the key game changers that we'll be seeing in the following quarters and following years. This is a slide which I actually wanted to maybe take a few minutes to explore, and then maybe towards the end, we can also have some Q&A around it. On the left is the traditional model, an inverted pyramid. Car manufacturer talks to tier 1, talks to tier 2, who in turn talks to semicon companies like us. Very traditional model, very linear, not allowing collaboration, not allowing understanding, not allowing exchange of ideas. The new ecosystem is where everyone talks to everyone. Semiconductor companies will now talk directly to the car manufacturers. Not to exclude, of course, the tier 1s and tier 2s, but probably tier 1s and tier 2s may be pushed to the sidelines. We at ST have formally announced that we have an engagement going on with Volkswagen, where over the course of a couple of years, we'll be defining and we'll be redefining how a car experience should look like, what a car system should be, what a car architecture and semiconductor architecture should be, and what should be the SOCs around it. So we've had some very fruitful starting points out here, and you will see a lot more announcements coming this way. This is a model which I guess will be adopted by more and more semicon companies. Net, for the consumer, for you and for me, who love great cars, who love to be in a great car, I think this will be a big bonanza. And for the industry, this means that faster innovations, more demanding innovations, which will really see faster cycle times, and essentially get into a car quickly. This is a dilemma which all of us in the automotive SOC industry face. The expectation from the chip designers and from the SOC companies is that we need to have products which are more consumer-like. Better performance, better power, lower area. Exponential growth in the complexity of these products. There's tremendous cost pressure. The mission profile of these SOCs is getting harsher and harsher to the point where it's very, very hard on the engineers because they have to meet the same time to market. They have to do this a lot more faster, and they have to do it with lesser resources. And at the same time, quality and reliability still remains the #1 priority. This is a mission-critical situation, so quality and reliability cannot be given a go-by. So this is typically the various challenges within the automotive industry, but I see no respite on quality and reliability. This has to continue. I just want to take a quick minute on talking about the technology process, because no automotive semiconductor can be defined, can be designed without the supporting technology. So we need secure technologies from the foundries. We need extremely high amount of safety. The technology needs to be power lean. Once again, zero failure, non-negotiable, has to be zero failure enabled, and has to have the ability to tolerate and give me harsh condition managed nodes. So our various foundry partners are working very hard on this, but this also needs significant input coming in from us, the silicon companies. So maybe I think I ran faster than I intended to, but okay. Here are some of the key takeaways. Disruptive trends are clearly visible. They are radically shaking up the ecosystem and the way we operate in it. Semiconductor content per car steadily increasing over the past decades and accelerated to 2.5x just over the last 4 to 5 years. Automotive semiconductor demand has become totally uncorrelated to car production. You could have less number of cars being produced, but the amount of semiconductor that we will sell is still going to be very high, because per car, the amount of semiconductor that is being used has grown exponentially. Electrification and digitalization of a car disrupting the silicon content and the ecosystem. And of course, on a lighter note, those of us who are on the job market should seriously think about options within the automotive semiconductor companies. So with that, I end my small talk. I'm open to questions if we have some time.
Can you tell us in which technology node all these chips are in the automotive industry? Is it at 28 or 45 or?
Automotives are not so easy to adopt into lower nodes, into cutting edge nodes because of the ROI or the benefits which you can reap from it. But having said that, all the way from 28 nanometer down to 5 nanometer.
Yeah. So talking about the automotive industry, so is there any particular segment like cars? Is it just cars we're talking about, or is it like it can go all the way to bikes, bicycles maybe?
Right. Obviously, automotive industry is everything starting from e-bikes to real motorcycles to cars, light commercial vehicles and heavy commercial vehicles. For keeping the talk simple, of course, my focus has been mainly cars, but you're right. The amount of silicon content, be it on a simple e-bike or a regular motorcycle that you drive here in India, has also equally, in equal sense, grown and will continue to grow. And we anyhow have very simple applications. If you look at some of the food delivery services, they're all driving e-bikes. That's all. There's a lot of silicon content into it. So equally applicable for all forms of automotives.
Hi, one question. You talked about having a lot of electronics into vehicle, and it's going to be increasing day by day, and innovation has just begun. So the question is there any effort on having a semiconductor automotive consortium which kind of enables the future technology, future R&D, and does some standardization across?
Yes, I think this is the need of the hour. I'm quite sure all our company executives, all the bodies are working pretty hard on it. There is some amount of standardization which is happening, mainly in the space of safety and certain interface protocols. But I think more needs to be done.
What is the gap between this autonomous driving versus the connectivity?
Sorry, I could not hear. Please repeat.
Okay. What is the gap between this connectivity versus autonomous driving? You need a lot of connectivity, right? Like 5G and plus should come, right? So are both developments are going in sync, or is there any gap?
So autonomy needs a lot of data crunching and a lot of exchange of information. I don't believe there is a problem with connectivity. I don't believe there's a problem with 5G. 5G exists as a technology, proven, already there, bandwidth is available. I think the maturity of L4, L3, L4, L5, I think this is not up to speed yet. Of course, if you go to North America, I think you'll see significant advancements out there. But that's only one use case. Maybe some of the speakers after me could answer something on this direction. But I think the autonomy part independently has to go through a little bit more evolution. 5G is already there. The infrastructure is there. So that's my comment.
Okay.
Thank you.
Thank you. So thank you so much for such a inspiring and knowledgeable talk, and I'm really excited about that L2 2.5x to 5x. That's what he said. I assume they would come probably, as he said, probably go up to 10x, and look for that time to come. So thanks again. I would like to request Mr. Sanjay Gupta, President and CEO of to kindly come on stage and So let's proceed forward. Next in line, we have founder and CEO of Saigen Energy Private Limited, Mr. Venkat Rajaraman from your own city of Hyderabad here amongst us. So let me take privilege to introduce Mr. Venkat. So he's CEO and founder for Signage Energy, and he's an advisory committee member of National Center for Photonic Research and Education. He has over 25 years of experience in product design and engineering management. Prior to that, he was CEO of SUCAM Power System, most of us know. Earlier to moving to this renewable energy space, he was vice president of engineering at Portal Players, a company that was acquired by NVIDIA Corp in 2007. Previously, he has worked at Sun Microsystems, USA, and he has done master's degree in electrical engineering from Stanford University and done multiple specialization, and now focus on the Indian origin products. So let me welcome Venkat on stage.
Hi, so I am sandwiched between two semiconductor stalwarts, right? So you heard a lot of stuff about semiconductor. I am a non-semiconductor guy, at least for the last 10, 15 years. My semiconductor stint ended with NVIDIA when it acquired Portal Player. I had been on the renewable energy side, on the energy storage side for over a decade now. And energy storage is for, at least for the last 6 years. So in this talk, I'm going to be focusing, on energy storage. And I'm going to be talking from a practitioner's perspective, right? And lot of slides from Ravi is going to be very useful here because I imagine that it sort of piggybacks on all the things that he had mentioned about a semiconductor. Of course, some slides may be slightly historic in nature, and some slides I'll skim through unless if you have any questions, we can take it up during the Q&A. I just want to start off with a very brief about CIGNI so that it gives perspective. There is no marketing pitch here. We started energy storage in 2017. That's when we did the first one for a distributed renewable energy in Northeast India. We have done over 50,000 of these installations, right? These are all standalone distributed renewable energy with storage. Of course, our BMS technology also got the IEEE award. I'm sure the engineers know about the importance of that. As part of the startup journey, we raised some money as well. 2018 was our Series A round, and last year we raised our Series B. So far, we have powered over 75,000 vehicles, electric vehicles. And two things I realized from Ravi's talk. One, when you say SOC, right, for the semiconductor engineers, we know what an SOC means. For a battery engineer, SOC is state of charge, right? I realized that there are, and similarly, L2, when he mentioned, there are L2, L3, L4, L5 vehicle categories, whereas we are, there are a lot of acronyms which I'll try to avoid so that there is no confusion. So let's talk about origin. I think I'm going to go back to Ravi's earlier slide. 1900. So this is the, the Fifth Avenue in New York, where you would find, everything is horse-drawn carriages, right? Except for one motor-driven vehicle, right? That was 1900. I think 1900, 1908 is when Ford came out, and so on and so forth. You fast forward 13 years, actually. Everything is, is motor vehicle, and there is only one horse-drawn carriage. This is a very famous Tony Seba slide that some of you may have seen. Two things, 1900, I know a lot of things about how do we make horses faster, right? How do we make, go for a longer distance? How do we make that it eats less? How do we take care of the, the poop from the horse? This was a big problem during that time. But the industry transformation happens, and these days the revolution happens much, much shorter than 13 years. I think the 2.5x that Ravi talked about is an example of that. And the EV disruption that we are seeing world over, definitely for India, is here now, right? It's not in future. We are talking about what's happening right now. Right? So now let's talk about what is driving it, right? Driving, the simplest form of driver for EV is, cost economics, right? Today it has been undoubtedly proven that if you have an EV, you know that your running cost per kilometer is much lesser. And of course, the rising fuel cost, rising concern about pollution, all of them are, aiding this journey for EV. And then, of course, the market potential is very high. India happens to be one of the largest market as well. I'll talk about it in the next slide. Indian government is also, we have a 10,000 crore scheme, which is called as a FAME2 scheme, close to over $1 billion, okay, as a subsidy for making sure that the electric vehicle is, you give the push for the industry. Just to give you a perspective, China has an incentive of $100 billion actually. So we are there, but we are still not there yet, right? We still have a long way to go. You take a look at any think tank that you talk to, whether it is Niti Aayog, whether it is CEEW, whether it is IESA. Niti Aayog is the most aggressive one. They believe that by 2030, 80% of our two-wheelers and three-wheelers will transition into electric vehicle. The rest of the think tanks are slightly more conservative. No matter how you look at it, you are looking at an upwards of 5 to 6 million vehicle in the next, by 2025, 26. And this is going to be upwards of 10 million vehicles, in this decade, right? Huge number, okay? I'm not sure if you're able to sort of fathom in terms of how it is going to go. So this is the first point. So which means that there is an opportunity which is here. And the most important thing is India's ecosystem is unique, okay? We talked about in the last one about a lot of things about cars, right? Today, India runs on two-wheelers and three-wheelers, okay? So if you were to look at it, over 80% of the vehicles on the road is two-wheelers and three-wheelers. Okay, so which means that when we are focusing our innovation, right, our technology, it's absolutely imperative that we focus on what matters to us most, right? So that's the first point. And of course, the way in which this industry is evolving, there are a lot of new mobility players who are out there, right? Companies like Bounce, Ogo, where you just go there, hire the vehicle on the road, take wherever you want to go, unlock with your app, and then leave it. If once your job is done, somebody else will come and take care of the vehicle. So these are all newer ways of e-mobility. And of course, the two-wheelers and commercial three-wheelers are on the fastest mode of adoption, right? So clearly, the ecosystem in India is very unique. Now let's talk about what is driving EV, right? What is driving EV is simply the batteries. Okay, so I think, clearly if you were to look at the growth of EVs and the cost reduction of batteries, right? Clearly they are, sort of inversely proportional, right? And if you were to sort of see in terms of how this has happened over the last, this is over a decade now, as the cost of batteries have come down from over $1,000, right, by 2010, now we are talking about between $130 to $150, depending on which technology that you use and so on and so forth. And the EV adoption is directly proportional to how the cost have come down. Okay, let me see. Yeah, so this slide I skip it for for the folks out there. The most important thing is there is a lot of semiconductor that goes into batteries. Okay, it's not very evident, but the amount of algorithms which are needed, the amount of semiconductor that is needed to make the battery safe, to make the battery reliable, is humongous actually, right? Of course, the leaders like ST and others are here. So let's. Yeah, so the battery evolution, I'm going to slip this slide, but the point is this all started over 30 years back. Lithium is not a new technology, It looks like nothing has changed, but quite a bit of change have happened on the lithium battery in terms of underlying technology, in terms of the battery management system that were to happen, and in terms of having digital twins so that you can sort of make sure that you are able to handle this through digitalization and cloud and so on and so forth. Let's talk about the global capacity for batteries, right? So today, if you look at it, this is the numbers for 2020 in blue and 2030, which is in gray, right? You look at it, by 2030, we would have 2,400 gigawatt hour of storage, right? So these are all plants which are either commissioned or in various stages of construction, okay? And if you see the flags there, we don't find an Indian flag there yet, right? So today it is ruled by, of course, China, followed by South Korea, Japan, and US. Okay, we are not in the picture yet. On 2,400 gigawatt hour, our current plan, under the ACC scheme, if we were to sort of follow, we would end up doing about 50 gigawatt hour. So which means that we are less than 5%. Again, just to put things in perspective, we have a long way to go, actually, right? So given that, is this growth good enough, right? Another question is 2,400 gigawatts good enough for that? The answer is no, right? The reason for this is, of course, there is a transition towards electric vehicle, which is going to require bulk of this energy storage. There is also energy storage for renewable energy application, right? Today, with the onset of solar, India talking about 450 gigawatt of renewable energy, storage will have to go hand in hand. So the storage is for renewable energy, the storage is for telecom, the storage is for rooftop solar, and so on and so forth. And we still, may be needing more. I'm not even talking about other technologies here, right? So given that, let's also talk about, there is a lot of global geopolitics happens on the lithium batteries, right? One, we all know that lithium is available only in very specific places, right? Either in Australia or in Latin America, right? The processing of these metals happen predominantly now at China, right? So pretty much all the minerals that are mined, they end up coming to China for processing. And if I were, for example, Tesla, right? What do? I take the processed material, I send it to my gigafactory in Nevada. Again, it travels, long distance, and then from there it goes to a, automotive manufacturing plant, either in Fremont or in China. There is a huge amount of transit that happens. These metals, they traverse about 50,000 miles. Right, before it gets onto a car. The question is this sustainable? Is this the right thing to do? We'll talk about it, right? So there is no right answer here, but I'll give you my thoughts here. Of course, there are a lot of government policies. The EV adoption that we are seeing is simply because of coming together at the right time with right policies and so on and so forth. But I'll skip the slide for want of time. Again, so India is embarking on battery storage. We call that as an advanced cell chemistry battery. So what India said was, listen, I don't care about the underlying chemistry. You give me high energy density. You give me higher cycle life. I'll give you more subsidy. It's as simple as that, right? So which means that if I were to have a cell chemistry which is maybe 4,000 cycles, and then I'm able to give upwards of 200 watt-hour per kg, then you get a higher incentive. So this is, as part of the ACC PLI scheme, there are about 5 players who are now embarking. This cell, we would be, it will be ready in the next 3 to 4 years' time. And of course, there is going to be a lot of localization which will happen post that. Yeah, so what is the market opportunity for India? We, conservatively, if you look at it, we are talking about an 80 gigawatt hour. And if you were to look at an optimistic scenario, this could double, right, by 160 gigawatt hour. Again, these numbers are anybody's guess. We talked about the 13-year adoption. I would not be surprised if we were to exceed 200 gigawatt hour as well, because there is a, the inflection point is here. And I think you mentioned, human mind cannot fathom the exponentiality, and this is one such case here, actually. Raw material availability. This slide is a little depressing for all of us here, in India. Look at it today on the left-hand side. You will find, the EV followed by the battery cell chemistry, followed by cathode and anode processing, then chemical processing and mining. So this talks about the share for India in the global market. Other than EV, which is less than 1%, we pretty much have 0% in all the other ones, whether it is, cell or cathode or anode manufacturing or chemical processing. You would find that yellow color, our neighbor here in all the places. So they pretty much rule the roost there. Clearly, this is going to be an issue for us, right? So clearly, I know that the think tanks are looking at it very seriously, but the point here is we have got to find a solution for this, right? So if you do not own the mines, if you do not own the processing, there isn't much of a headway in terms of where we can go. So what's our alternative, right? What we could possibly do? I have to maybe come there, yeah. So one excellent opportunity that we have is on recycling, right? We also call that as an urban mining. We have over billion cell phones, tens of millions of electronic gadgets, and the batteries which are there, world over, it is now shown that you can recycle it in a very energy efficient as well as with a zero effluent way. We have an opportunity here, right? So in fact, tomorrow there is a talk in Delhi on recycling per se. The opportunity here, if you were to do this right, this could take care of all of our requirement. We talked about an 80 gigawatt hour of requirement. Recycling could handle that for us completely. And India could be the urban mining capital of the world, right? So there are quite a few startups which are there. This not only needs chemical expertise, but I also believe this needs semiconductor expertise as well, actually, maybe that's for a different time. So given that, let's talk about the design itself, right? Most important thing is we saw, India rides on two-wheelers and three-wheelers, right? So today, two-wheelers, the most important thing is you have a very small space there for the battery, because these are all smaller form factor vehicles. The most important thing is you also need to focus on the cost, right? If the cost were to be much higher than your traditional an ICE engine vehicle, then you may end up not buying. The market may not adopt. So we need very high temperature range for these battery packs. You need to have compatibility with various types of battery management systems. You also need to handle thermal management without going in for an active cooling, right? Because you don't have space and so on and so forth there. And of course, you need a high cycle life, followed by it has to be modular, right? Especially if you're talking about battery swapping and so on and so forth. So we really need to have a solution which are India specific, right? So I think that's the key point that that I would like to highlight here. Maybe I may need to come here for this. So we may need to design some of the solutions which are tailored for India. I think if I were to convey one message to all of us here, that would be this, right? So which means that whatever that we have designed for the Teslas of the world may not work directly here, right? So that's the one. Very briefly about the technology. Today, lithium ion is a very standard term, but there are multiple underlying technologies which are there. The one most prominent one being what is called as a lithium ferrophosphate, which is the LFP chemistry. The advantage with that is very high safety, very high cycle life, but lower energy density. The other one is what is called as an NMC chemistry, which is the nickel, manganese, and cobalt. Today, NMC chemistry has a high energy density, but it has issues with respect to safety and cycle life and so on. Quite a bit of work which are going on where there is an there is an intervention to increase the nickel content and reduce the cobalt content, right? Because cobalt is sort of mined in unsafe conditions in Congo and so on and so forth. And there is also a lot of work going on in solid state batteries and also solid electrodes as well, and lithium metal anodes and so on and so forth. these are all the ones that is going to happen over the next 5-7 years. So what I want to say is that, this is continuously changing as well. There is quite a bit of work which are done on the underlying technology, and I would imagine that it is going to evolve in terms of safety, in terms of energy density, in terms of cycle life over the next several years. And so if you look at the next generation electric mobility, I think a lot of semiconductor which is here, I think Ravi was talking about $1,500 for a car. Two-wheelers are no less, in the sense that today if I were to see battery management system, vehicle control units, and your BLDC controllers and so on and so forth, it's easily about upwards of $150 to $200. So imagine a market share of 80% of the vehicle, where you're talking about a 20 million vehicle on a $200. You're talking about a huge opportunity there. And of course, the battery, I'm talking about energy storage here. So battery management system, again, in addition to traditional sensors for monitoring, voltage, temperature, current, and so on and so forth, you also talk about, the state of charge and state of health, right? And then the future technology includes quite a bit of work. How do I make sure that my batteries can be warranted, right? How do I provide insurance services on this battery? How do I provide state of functions on these batteries, and so on and so forth? So this is one level which is happening on the semiconductor inside the battery pack. On the other level, what is happening is there is a lot of work which is happening on the cloud platform as well, right? So the entire battery today is now getting transformed onto a cloud where there is a digital twin, and depending on whether you are driving a vehicle in Rajasthan or whether you are driving a vehicle in Srinagar, it can adjust your parameters in such a way that you can, sort of increase the life of the battery as well, right? by changing your, cutoffs, thresholds, and state of depth of discharge, and so on and so forth. And for all of them, you would need, semiconductors for, for online monitoring, for over-the-air upgrade, and so on and so forth. And there is a lot of role for AI as well, right? I'll give you one example maybe in the next slide. Battery swapping, I'll skip this slide for want of time. Let's talk about new ways of electric mobility, right? I think I'm rehashing something similar to what Ravi had mentioned. We have all seen this news about Hertz and Tesla announcement, right? It happened a little over a year back. The moment Hertz announced this deal that they are going to buy 100,000 Teslas, Tesla's market capitalization has crossed $1 trillion, right? I'm sure many of you may have seen this. The question is, what was, electric vehicle today, is this because this is clean and green vehicle? Is it because you are using a cleaner fuel, or is there something else? The tipping point, what we realized, is not because of, the clean and green or a carbon emission and so on and so forth. The main reason for that is today, if you were to sort of go to an airport in US, going and getting your rental car itself is a mammoth task, right? You come out, go into, your, the car, the rental station, stand in the queue, get your key, go to the car. Today with this, you collect your baggage, come on the curbside, your Tesla comes, you unlock it and then drive away, right? So there is a very different way of looking at mobility. And of course, the case is everybody knows about it, right? Connected, autonomous, shared, and electric. I think that's the direction that, this is going towards. I'm going to end the slide in the last 2 minutes. Safety is a key aspect. I don't think we'll have time to talk about it, but the importance of semiconductor in safety cannot be undermined, right? So the entire battery safety depends on battery management system, and battery management system completely depends on how good a semiconductor that you have got. But today there is a lot of talk in India about, can I get a higher range? Can I get a faster vehicle? Can I get a larger cycle life, and so on and so forth? But the question that we should all be asking is, can I get a safe vehicle first, right? I think, so because battery is, trade-off across all parameters, right? So today, when we are trying to optimize on some of these vertices, you sort of tend to compromise on the safety. Most important one is get the safety right and then get optimize on the rest of the parameters, actually, right? So Yeah, so in order to do that, a good CAE analysis is a must, for those engineers out there. Today, with the latest tools that you have got, you can actually do a fantastic, mechanical, thermal, vibration, electrical, and all types of analysis. And if you do that right, your design is a no-brainer, right? Most of the time, what happens is we sort of take some designs which are done elsewhere, right? For example, an European country or an US, and then try to apply it in India, where the temperature conditions are different, the dust conditions are different, the humidities are different. That's when it fails, right? So if you sort of do this right for India, then you have a good design. I'm going to skip this slide again. Yeah, so most important feature is also called as a cell balancing feature, which is there in the battery management system SoC. This, when it is done right, it extends the life of the battery. Again, other features such as temperature dependent charge, discharge, and then power dependent charge. There are quite a few algorithms which are there. Let's talk about the role of AI, right? Batteries are very complex nonlinear systems, right? So today, one of the problems that I have as a practitioner is I import the cells from China or from South Korea or somewhere. When I get these cells, I get a few lakhs of cells, right? They all say that, hey, these are all tested, right? Take the test report. This is what it is. But there is no way for me to conclusively say that this is a good cell or a bad cell. Okay, this is the biggest problem that industry faces because, first, I don't have a local manufacturing. I am dependent on imports. And when the import comes, there is no way I would know that these are all good cells are there. So this is one such research that is done at Stanford. Take a look at it. They have done this 124 commercially available LFP cells. They took it through these various cycles. They generated this data. Today, they can conclusively prove that within first 5 cycles, so that means that within 24 hours, I can tell you whether the cells are good cells or bad, to an accuracy of over 95% actually. Imagine the kind of thing that would help especially the manufacturers, because this would change in terms of how we are looking at our how we are looking at the health of these, battery packs and cells and so on and so forth. Of course, this can have multiple advantages at the manufacturer's end, at the OEM end, at the customer end, and so on and so forth. So AI has a huge role to play, in energy storage, but overall in electric vehicle, as Ravi talked about. Electric vehicle prices fall, predominantly due to battery pack prices. Yeah, so there is one Wright's law, W-R-I-G-H-T. Many of us know the Moore's law, right? For the semiconductor guys, I don't have to tell that. Wright's law says that for every doubling in capacity, okay, your cost of battery pack comes down by a certain %. And this has been proven true for the last 12 plus years, actually, right? So which means that if you were to extrapolate on this capacity, we are talking about 550 gigawatt hour to 2,400 gigawatt hour. You're talking about, more than, quadrupling of this capacity. For sure, the cost is going to come down. So with that, maybe I will, I think, 80 billion he talked about. From an electric vehicle, from an energy storage perspective, it's a $200 billion operation. Not for semiconductor, but for the energy storage industry as well. So summary, EV is undergoing inflection point right now, right? So, I believe that two-wheelers and three-wheelers are the ones that we need to be focusing on, fastest mode of adoption. We could be the urban mining capital of the world. So focusing on sustainability and recycling is very important. We absolutely need differentiated solutions for India, right? I don't think an existing Western solution would directly apply to us. And our goal will have to be 100% safety on these batteries. AI, big data, and analytics have a huge role to play. And connectivity is disrupting mobility in a way that we have not imagined. So that's, with that, I think I'll conclude my talk. Thank you.
Thank you, Venkat.
I had a question on the form factor and the electronics that goes inside. We work on some of those. I'm just surprised that instead of focusing on the functionality and the cost, people are trying to put, ADAS systems, that are not core to the, the two-wheeler or three-wheeler. How much of that cost, can be taken out and the adoption, increased much faster? Because a lot of gimmicks in the electric vehicles. How much is that worth?
Yeah, great question. So, see, today I'll tell you that, if I were to sort of look at it from my perspective, up until a year back, electric vehicle was about 30 to 40% more expensive, right? If you were to look at a two-wheeler, for example, a high-end two-wheeler, where will these guys go? They will have to sort of show some, your GUI on the screen, your, functionalities in terms of, various sensors and so on and so forth. But Indian consumers are absolutely brilliant guys, right? So they are not going to. So if you look at what had happened, all the extra features which were not so important for the consumers. If you see tomorrow, by the way, is an auto expo. There are a lot of new vehicles are getting launched. Many of those features are going out. Actually, we need. I think we need kitna deti hai kind of vehicle, right? So which means that absolutely rugged, absolutely reliable, and something which can meet our requirement. And I think, yeah, so it's going through that phase of transition actually.
So a good overview of EV. I add up to this question where one small video itself is taking me 1 hour battery out, and I'm hopeless about my battery charging. So the situation is such a way, my battery life and other things, I'm including a AI engine in my system, normal vehicles. How much battery life it can take away is the questions people will be raising. AI on an edge, or it is my battery will itself will interrupt and say it to the whatever is a system, networking system, maybe the better future than including very consuming applications on my automotive. So what do you say?
I imagine that's a comment to what you have mentioned. But I also believe that, low power semiconductor is going to be key, right? Talked about it. So I believe that it is all going to be digitized, it is all going to be cloud controlled, it is all going to be data driven, right? Whether we like it or not, that's the direction it is going. So there is going to be an explosion in terms of how, this battery performance versus how much of, computation that you do. But that's where I think all the smart, all of us are here to resolve that problem only, actually. Thanks.
Thank you.
Yeah.
So, okay, the last question for the...
Yeah, but talking about the, as you mentioned about the geopolitics scenarios, and if we are talking about renewable energy and, carbon neutrality, so even the electric vehicles is not going to be the final solution. So what are the, if you can throw some light on, what kind of research is going on in the field of hydrogen as a fuel or maybe something?
Yeah, great question. I don't think we had time to talk about the alternate chemistry. But I think, there are multiple alternate chemistries which are going to, will have, hydrogen being one, especially, with kind of work which is being done and India's focus on, green hydrogen and so on. Yesterday, by the way, the cabinet approved the green hydrogen policy as well. But the point is they are all meant for certain applications, right? So today, I don't think you can take an hydrogen one and put it for a two-wheeler in India, right? Same thing is true for maybe graphene or, aluminum air-based batteries or, sodium-based batteries and so on. Each one of them will have a certain niche application. So that is one. So which means that if somebody were to say that is there an alternative to lithium today, guys, I don't have I don't think there is none for the next, at least this decade. So which means that we got to get our act right on the lithium while we are working on this newer one, because lithium took us 25 years to get to where we are now. Second part of the question is more involved in terms of, how do we make sure that whether, if one is polluting, how do we say that this is this clean? Tougher question. I don't think I'll, venture for an answer now, but that will call for a detailed discussion separately, actually.
Okay, thank you so much, Venkata, and we'll conclude his talk. So, and Venkat, he'll be around during the tea break, and probably you can still catch up with him if you have still more questions for him. So, Venkat, your concluding remark, 35 years it took us to get to the lithium, and I'm looking for that very first slide of yours. It took 13 years to get, move all the non-mechanical things to get all the mechanical stuff. So I assume whatever next comes up, be it hydrogen or anything else, would take certainly, later than this. And thanks for the rights law, you particularly mentioned, so it was quite insightful. So a big thanks to you, and let me now invite Mr. Shrikant, who's country head from Microchip, to please come on stage and honor Venkat with a moment of thanks. Again, a thanks to AV team for the background music. Okay, so let's move forward. We have the last concluding talk before the tea break, and that is again by one of the renowned industry leader and my fond colleague, Mr. Amardeep Punhani. So let me introduce Amardeep. So he's Senior Director, R&D, Digital Design and XP India. He has over 23 years of experience in VLSI industry. He holds BTech from IIT Roorkee and a master's from IIM Lucknow. He has been engaged with automotive, SoC, IP development and NXP for last 1.5 decades in various roles, from chip lead to global digital IP manager to now senior director of digital design in MCU MPU engineering group. Before NXP, he also worked in various capacities with Agilent Technologies, NEC Australia, Ultima Corporation in Japan. So Amar will be talking about automotive vehicle architectures for sustainable and safe mobility. So a big round of applause for Amar.
Okay, hello everyone. So seems I'm between you and the tea, so I'll try to go fast here. Excellent presentations by Venkat and by Ravi, and was very insightful. And when we are all talking about cars, I think a lot of things that you will see here is, a common theme that is coming up, because we are all part of the industry and we are all seeing the same trend. So, but yeah, hopefully, something to take home from this presentation. Okay, so I've been engaged with the car industry for some time now, as was being said. So have been looking at it, closely for a few years, and we can see a significant change, a significant trend, showing across few of these areas. And when we look at it, a vehicle, it has really transformed from what it was, say, 15 years ago to today, and huge number of changes happening in variety of areas. And just have to basically keep seeing how complex the whole thing has become. If you look at a car, it is actually the most complex edge device that we see on the planet today, and that is where the whole thing lies. It has all the complexity of a networking device. It has all the complexity of an industrial device. It has all the complexity that would go into as an edge device, because it has multiple sensors, it has multiple actuators, it has a huge amount of data that it is producing at any point in time, and that data has to be connected to the cloud. The consumer is there inside, who's actually doing, who's experiencing essentially the various things that are there inside the car. So pretty much, so many things happening. We actually call it like a factory on the wheel at this point in time today in the industry. And anything to do with the, with the consumer world or with the edge, will actually come into picture when we talk about a car. Now, the way the architecture has actually moved forward, there are few very interesting things that will, that are coming into picture. Okay, so if you look at the way the platform actually has evolved of the car, there is a huge amount of focus on the safety and the security of the person itself, of the car, and so forth. The vehicle dynamics, more and more power associated with the car, more and more need for stability because we are having to run the cars at very, very high speeds. So, you need those things that will be there in pretty much every car, which comes with the vehicle dynamics. The vehicle networking, like I said, about the in-vehicle networking, which is for inside of the car and when we do the connectivity to the outside. So that actually requires a huge amount of security as a very important feature. We have seen many of the cases recently when, or in the past when the hacking happened and somebody was able to actually control a car on the highway sitting in their room, and we could see the car wavering off maybe running at 100 miles an hour, and then it was suddenly wavering. So these kind of things we need to avoid, and networking actually becomes a good way for a hacker to enter. So it has to be a huge amount of security built in. Body and comfort needed in each of the cars anyways, because the consumer is getting more and more refined and they would want to have that built-ins. And these are, some of the things which are required as a platform. But then there are many optional features as well that will be there, which will be needed by some of our OEMs when they're manufacturing the car. They want to be able to have variation across the models of the car. They want to have variation across the country. We have seen that the cars that will be coming probably in India versus the US versus the Europe, they'll be quite different in many of the cases. So those variations, which we call the optionalism, which is actually a huge challenge for the R&D community, but is actually much, much needed for the manufacturers themselves. So that brings in a significant challenge as to how do you basically come up with an architecture that can handle all of these things in a cost-effective manner and in an efficient, sustainable manner for going forward. And believe me, these kind of things are there also in two-wheelers today. We know that in India, two-wheeler is becoming a lot more important, and huge numbers is what we see around. Both of these, so any of the things that I'm talking about are actually relevant for both the cars and the two-wheelers. So that's a significant challenge that we see. The other one is, if you look at the trend, and Ravi was actually bringing out these trends pretty well in his slide. So if you look at the way the trend is going between what we saw say 20 years ago and what we see say 10 years from now. So the total number of processors that are there in the car is maybe 60 odd processors, let alone the chips. So we of course have 100 to 200 ECUs as we call coming into any of these devices. If you look at the number of lines of code that is there is about maybe 200 million odd already, and it's going to increase. And I think we all know that the amount of software that is there in the car today is actually more than what a Boeing aircraft has. It's already today happening. And we can only imagine what will be the case, say a few years from now. Wiring, it's sometimes not really easy to imagine, but wiring is such a huge problem for car manufacturers at this point in time, because it's about 75 kg odd worth of wiring that a car is carrying at any time. So it's more or less, one additional passenger always there in the car because of this wiring. And something absolutely has to be done to manage this, because otherwise this just continues to grow and grow. The data generation that is there in the car is already in the range of gigabytes. It is absolutely going to be there in form of the terabytes going forward. The driver is being monitored, so a lot of that data has to go to the cloud. We would want that from the safety perspective. We'll obviously want to have that secure. There are so many sensors, and the data is needed by the insurance companies, for example. The data is needed by the car manufacturers, for example, to be able to manage the health of the vehicle and so forth. So with this huge amount of data that is coming out, you need to be able to also consume that internally and also be able to transfer that. Now, what kind of architecture would actually make that work is the question that is there in minds of all the OEMs, and therefore a challenge for all the chip manufacturers as well. The other interesting problem, we always say that software is going to be significantly there in the vehicles, but so there's already a lot of software that is there in the cars. And today, with an estimate, about 150 million lines of code is already there, is already written for the cars, and it is available with all these big manufacturers. If you see, if you see around you, the BMWs, the Audis, the Fords, and the Volkswagens of the world, they are already carrying a huge amount of software. Now the problem is some of this software was actually written 10 years ago, 15 years ago, and it is so large at this point in time, and so many man-months have gone into actually building this software. The companies are stuck. You can't throw that away. But if you go and, if there is a problem, if you want to go and debug it, if you want to handle it, it's almost impossible because it's a maze, it's a spaghetti, it's absolutely impossible to actually go and play around with that code as well. So you have a huge amount of code, and then you are stuck with, how to handle that as well. And because of these changing consumer needs, the need for actually building that software further is actually growing as well. So you need an architecture in the vehicle which is basically able to help us scale from the current situation, or all the problems that we are hearing, to to maybe say 10 years later, where all these things are able to still move forward, say maybe 10, 20, 30 years, we can still continue to move that forward, but be able to still carry what we have so far, and so that we are not actually reinventing the wheel when it comes to some of these development. So one key thing that is coming up in a very, very big way in the vehicle architecture is a domain and zone-based architecture. So this is something that is, is strongly there now, and pretty much every chip manufacturer is actually talking about it. They are doing their architectures in this manner, and you will see the OEMs also having, pretty much every discussion that they are having for the next generation of vehicles is keeping the domains and the zone in mind. So what are these domains and these zones? So domains essentially divide the vehicle into the various, various regions, and the more from the software perspective. So we'll have these domains that will actually ensure that we are having, say, a variety of software in various areas, say, related to maybe the ADAS aspect of things, the vehicle dynamics aspect of things, the body control aspect of things. And when we separate these out, we are actually also looking into virtualization so that each of these domains are absolutely isolated from each other, and they are able to work basically with, in some cases, even the same hardware, such that they're not interfering. So there's a huge concept around the freedom of interference, which will ensure that with the common hardware, you're basically able to manage a lot of this software and build over that software. And we are able to move these, say, older software into their various regions, and whatever, say, common work is required across these regions, those can still be managed, and then we can scale it up further. So domain focus is a key key area of work. The other is the zonal focus, which is required for simplified wiring and connectivity. So having the design actually into these, the zones, as you're seeing, the front zone, the back zone, and the left and the right. So that is also helping significantly with from the hardware side of things, how we can actually manage these out. So the various companies are actually trying to have lesser dependence on variety of semiconductor, because we've seen the last couple of years how the semiconductor has been a challenge. So they are actually looking at how they can use similar kind of semiconductor for variety of tasks. And when you divide these into zones, you can basically have similar chips that are actually there across the vehicle, and you can replicate these for certain kind of tasks and utilize that for the work. So gives the OEMs the advantage that they have lesser number of chip types to work with, and also helps them with the scalability. So this is a key significant trend that we see in the market at the moment today. The other significant trend, and this is second of the three that I'm going to be talking about today, and that is related to the software-defined vehicles. So Ravi was talking about it earlier about the software vehicle, and I saw Venkat also bringing this point in. So this is something which is which is significantly coming in. We have had mechanics defining the vehicle before, then we have had electronics defining the vehicle, and now we have software that is defining the vehicle. And this is where we see majority of the work happening going forward. In fact, OEMs today are telling the chip manufacturers, that we don't care what kind of hardware you provide, as long as you're also providing a software with it. You can keep changing the hardware underneath, but as long as the software is working, we are good to go, and we have scalability going forward. Now, there are various use cases that come into picture. One, of course, is the networking, which is actually required outside to the cloud or internally. So in-vehicle networking requires a huge amount of software. Then, of course, all the cloud services. There are service-based gateways that are there for a variety of things that the driver would be needing for various services related to, for example, the OTA and so forth. Then a significant amount of machine learning that is actually going on at any point in time, which for which the software essentially becomes important. So that is coming into place. We have, as I was saying, the sensors and the actuators. So that so managing that data also requires a huge amount of software to be brought in. And then, of course, there are a variety of entertainment aspects that come into picture. So each one of these today, if you see, require a large amount of software. And that is why, it is more, which organization actually has a better software, which actually is able to have a better work between the software and the hardware, is the one that is going to be having a better experience inside the vehicle, and that's where most of the innovation is today. Okay, and the third key move, which I think all our previous speakers were talking about as well, is around the EV. So the EV adoption is, when God used the word inflection point, absolutely that is where it is. It is at the inflection point, and we are seeing more and more usage of EV. And if you look at some of the data, so 2030, the expectation is that 57% of the overall global production is going to be EV. So some of the manufacturers we know are going to be 100% moving to that. They are absolutely moving out of ICE. We don't expect that to be totally eliminated by 2030, but this is more than half of the number anyways, so it's huge. If you see some numbers from 21, and these numbers have actually improved only since then. So already more than half of the vehicles in China actually are EV, and about quarter of them in Europe are actually already EV. So the numbers are significantly increasing, and we expect that to keep going forward as well. The legislation is also going pretty much in that direction, because there's no other way essentially to get that sustainability than going this route. Or yes, we have the challenge of how we handle the associated the metals, the elements that actually go into building that. But the thought process is that the way the innovation is actually going, we will eventually find ways of overcoming that. So you see a huge amount of movement happening in that area. And the last couple of years when the COVID was going on, the thought process was that there will be some slowdown, but interestingly, especially on the EV side, the companies are seeing that there has been no change at all or no slowdown at all. In fact, other things did slow down, but not on the EV. That has actually continued to grow still anyways. Now, how do you make that efficient? I mean, we know that we can't really we cannot really continue to build bigger and bigger batteries. We can't really continue to have, more and more basically metal going into that and make that very expensive. So what comes to rescue essentially is the technology and the associated software that goes with it. So the battery management systems that are there today, they are getting extremely sophisticated, and there we see the benefit that we have these the battery management controllers. So actually a combination of these three in any car that is actually EV is the most important. Without this, I don't think we can have any of these cars to actually be running for these longer amount of times. So a combination of these three is where most of the research is, that how we can make these three work together, including the AI ML based solutions, so that we can have, and actually having the safety and the security in place, so that we can have a good working between these three, these being the battery pack controller, which is actually the brain of the battery management system, wherein most of the data will be actually coming in from the cell module controller or from the battery junction box. So this is where most of the decision making would happen from the battery. Then the cell module controller is where each of the cell of the battery is actually being monitored for the kind of the charging levels that they have, and are they charging, are they actually depleting too fast, or are they actually charging too fast, so that we can have some temperature control around them, voltage control around them. So that is something that is being done by the cell module controller in a dynamic manner at all points, at every time. And then the junction boxes, which are actually looking at the currents and the voltage associated at the junction level, to ensure that we are also keeping them under the safe threshold at all point in time. So these three working together and ensuring that there is enough amount of safety built in, so that all the communication that is happening is also isolated, and isolated from the chassis of the vehicle is important. And having this combined solution essentially ensures that we are able to get a better battery life. In fact, the research that is there today tells that by having efficient solutions with these BMS, about at least 15% of the battery life can be increased easily by going these routes. And there's of course methods to actually take that even further, and that is where the effort or the research is going to be. Now, the next thing which is there is how basically we evolve these BMS systems going forward. So one thing which is important is basically bringing in the software, so connectivity to the cloud through these BMS systems, so that we can have the health of the battery very well understood by whatever is going on in the car, so that we can understand the health of the battery at any point in time very well. So that is very important, and that's where the future innovation is going to lie. And for example, there is also a few of the companies which are onto the battery swapping pretty extensively. For example, we have NEO, who already have a few million odd battery swaps done, and they are pretty active in China or in the Europe. So they end up relying on this kind of technology quite a bit, because you at any point in time know that what is the health of the battery. Is it aging too fast, or is it actually at a good healthy state? and what kind of swapping essentially is should be done, or whatever new battery is there, you can also at any point in time basically find out what the state of the battery is. So those kind of things essentially can be done by having these intelligent software being developed, which is currently where the essentially a lot of innovation is actually going on. Also, to be able to tell the consumer that when is a good time to actually charge the battery, or based on the driving style of the consumer, to be able to tell them that are they actually doing okay, or does it actually require maybe a different kind of style for them, when they should be charging, when they should be probably accelerating further, and any changes in their driving styles also. Those kind of things can be provided based on getting that feedback from the battery at any point in time. So and those things essentially help in improving the health of the battery in the longer run. So these things are, these kind of innovations will significantly ensure that we have longer sustainability of the vehicle and the battery going forward, which is key. But there are other things as well. So we have to be able to go beyond the batteries in terms of sustainability by design. So so one is the charging infrastructure. How do we ensure that there is a good amount of charging infrastructure around us, and the vehicle to the charging infrastructure connectivity, essentially, how we can have that brought in a more efficient manner is something to look into. So that is one key area being looked into from the sustainability perspective. Then having reliable networks, that is another thing that the OEMs and the chip manufacturers are actually currently looking at, as to how we can have these reliable connectivity networks to ensure that any time these batteries are looking, so anytime a consumer essentially is looking for support for their batteries, that can actually be provided. And to make all this happen from the sustainability perspective, it's important that we are doing it in a safe and secure manner, and essentially keeping it upgradable, so that the latest using the latest AI and the ML techniques is another key focus area that is there from the innovation perspective. So in summary, these are the three trends that we are currently seeing. One is the architecture changing completely in terms of the domain and the zonal way of handling the architecture of the car. The second is the software-defined vehicle. And third is all the effort that is going into building the software and the innovation around the BMS to have the electric vehicles more and more sustainable for longer run. And that's it that I had.
Thank you, Amit.
As there is a lot of AI and ML algorithms now, does the automotive industry also look at like formal verification approaches to ensure that these are running as per required?
Absolutely. So more question in terms of the methodology of how we basically build the chips. So absolutely, that's actually very, very important, because when we are talking about automotive, zero defect is one of the very important things. And having to have chips coming out which are actually absolutely without any defects, it's important that we actually use latest and greatest of verification methodology. So if there is one organization that needs formal the most, that is actually automotive. So it's a very, very extensive usage is happening in that area.
So let me invite Mr. Sangram Jina, who is the Senior Marketing Manager at Cadence, one of our sponsor company, and he's the Exhibit Chair for the VLSI Design 2023, to come and give a talk on. Thanks very much. Great. So we come at the closer of this particular first part of Industry Forum on automotive. We'll have a quick 15-minute tea break, and we have a very exciting panel discussion upcoming. The panel would be talking about India on the e-mobility highway. We have panelists from different walks of automotive segment here with Mr. Sanjay Gupta, who's representing Minda Corporation. Mr. Swapnil Jain from Ather, Mr. Reddy from Permanent Reddy from Vector, and Nitin Gupta from WD.
Good afternoon. We'll now have the part 2 of the automotive track, which is a panel discussion on India on the e-mobility highway. I welcome Preet Yadav, who's going to moderate this session. And Preet is a R&D SOC Technical Program Manager for Automotive Group at NXP Semiconductors. Prior to rejoining NXP in his second stint, he was working with Wipro as Analog Practice Head, Distinguished Member of Technical Staff, Wipro Senior Member, leading Analog and Mixed Signal Practice globally in VLSI Technology Group. He has 2 decades of enriched R&D experience in the diversified semiconductor industry. He is chairperson of IEEE Delhi Circuits and Systems Society. He is a fellow member of IETE, senior member of IEEE, life member of IMS and ISSE. He is serving as general chair of IEEE Asia Pacific Conference on Circuits and Systems, which is going to be held in November 2023. I welcome Preet on the stage. Preet, come.
I can't hear you. Good evening. Can you hear me? Little more loud. Okay. So thanks to the VLSI 2023 organizing team for giving us this opportunity to run this fabulous panel discussion. And let me get started to get our leaders from different industries to be here joining us on the dais. So let me start with Mr. Sanjay Gupta, who's President and CEO of Media Corporation. So Mr. Gupta, he is President, CEO and member of Executive Committee at Minda Corporation. In this role, he is responsible for Advanced Technologies Business Unit, which is focusing on automotive high-tech products for EV, ADAS, infotainment, sensors, connected mobility business, and whatnot. He is a seasoned semiconductor professional with about 27 years in this tech industry. He started his career with Motorola back in 1996. Since then, he has worked with some of the well-known brands in his professional stint, with most recently being at NXP Semiconductor as Vice President and Engineering Managing Director of India. So thank you, Mr. Sanjay, for joining us. Let me welcome our next panelist, Mr. Brahmanand Patil. He is President and Managing Director for Vector. Mr. Patil joined Vector India as the President and Managing Director in 2022. He's working towards building and enabling the local team in India to deliver high value to Indian customers. He's an electronics and communication engineer and advanced management graduate with product leadership and business management with an industry experience of about 23 plus years. So thank you, Mr. Brahman, for joining us. So let me welcome the youngest member of our panel, quite a famous name and face in Indian EV ecosystem, Mr. Swapnil Jain. He's the Chief Technical Officer and co-founder of Ather Energy. So Swapnil is an engineering design graduate from IIT Madras. Along with Tarun Mehta, he conceptualized Ather Energy with the belief in an electronics and connected future. Ather has built an entire EV ecosystem in India with scooters as well as public charging infrastructure. Both Tarun and Swapnil were featured in Forbes 30 Under 30 in 2008. Fortune 40 Under 40 list in 2017, 2019, 2021, And I assume again he'll be, in some of the other lists when he's like crossing 50. Thank you, Swapnil. Okay, so the last but not the least, Mr. Nitin Gupta. He's director at WD. So Nitin has over 2 decades of rich leadership experience in the area of VLSI design. He's currently managing global charter of state-of-the-art mixed signal IP required for Western Digital flash controllers. His area of interest are high-speed interface, low-power design, power management, clocking, and he has authored more than 30 patents and IEEE publications so far. So welcome, Nitin. Sanjay, who has spent more than 25 years already in the inside chip industry, and now seeing the other side of the table with Minda. And then Swapnil, who's making the end products, Ather showrooms I have walked across in many of the cities here. And then on the right, Vector, who's representing the software tool enablement. So I would like to put together a little recent news to put together, focus on this particular panel discussion. So India is kind of on the full path to become the 3rd largest automotive market globally, surpassing Japan. So this was the news a week back, and the results are yet to be out. And India is supposed to sell off about 4.25 million, and whereas Japan is expected about 4.2 million. And I hope these figures would come true in another some time. Japan was about 4.3 million until November, and I assume we're going to surpass. So it is the focus domain. We are going to be the 3rd largest market after China and US. So in this particular panel, we are going to deliberate how this country, which is having 1.4 billion population and still growing, and it is expected till 2026 we will be still in that trajectory. And only 8.5% of our households, they have vehicles. So there's a huge scope still left with us, which is more than 90% vehicles, 90% households to get some mobility, be it Ather two-wheeler, or be it a four-wheeler or any other segment. So in today's this discussion and deliberations, we'll get started with each of the panelists putting together their thought process in 3 to 5 minutes. And post that, we'll start our internal deliberations, and at the end we'll make it open to all the audience for walk-in Q&As. So let me start from my right, inviting Mr. Sanjay to share his thought process on this topic. Sanjay.
Thank you, Preet. And once again, welcome everyone to this discussion. So directly jumping into this topic, as I said in the beginning, from a macro view, India is growing at a GDP perspective. We are saying about 7%. We are the fastest growing economy in the world right now. And all intelligent people are predicting that we will continue to be the fastest growing economy and one of the largest growing economies for next 1 decade. And if you add the real GDP that comes to about 11-12%, the simple math is every 5 to 6 years our economy will keep doubling. And that's where this 10 trillion economy discussions are happening, that by 2030, 2032, we will be a 10 trillion economy. Now, if you just work backwards, what Preet said, every few years we see the news in the media, we became the 5th largest automotive, we became the 4th largest, and now we became the 3rd largest. I can guarantee this is not going to stop. Because India is growing at an organic pace, and this momentum that is being generated, a lot of factors are behind it, whether you call it the right government policies, whether you call it the whole digitization platform through UPI that got created. Another interesting fact was the number of UPI transactions that happen in India per day is equal to probably rest of the world and many more times that. Electronics and semiconductor ecosystem. On the top of it, we are talking about India to have a Make in India theory, because the electronics import can surpass oil import if we do not do anything in this regard. So from a government angle, very important. From a country angle, very important. And I think that's where electronics in automotive, being the fastest growth engine, is going to be the future. The same theme was discussed during the first three presentations. And I'm very confident that as part of this ecosystem player, we from Spark Minda are seeing now the shadow of this whole growth from the other side. As part of NXP, I was looking into from the other side. And the good thing is, from both angles, it looks equally exciting. So what our chip design teams are thinking, the same logic, the same theme is at tier 1 level, and the same thing is at OEM level. And when all ecosystem partners' wavelength is matching, that's where the magic happens. And I will just say in my opening remarks that this is truly an inflection moment for India. And if we just continue to work for a lot of collaboration among India-based partners, whether they are enabling companies, the service companies, or the hardcore hardware and software companies, we will make the products for India, which will be unique and which will have a growth trajectory than ever before. Because the time has come that India define its own destiny rather than just doing everything through import. And we all should be feel lucky after 10 years that if we are part of this journey in a very significant way. Thank you.
Great, thank you. Thanks, Sanjay, for your thoughts on how do we have our home-cooked recipes, taking the whole automotive to next level. So let me now request Swapnil, the youngest among us, to share his thoughts, how hold this EV momentum, from Ather's perspective. Thank you.
Right. So as we spoke about the entire the GDP and the automotive industry really booming up, I think again what we touched upon, that probably barely like 8.5% of the households still have a vehicle, right? And that's very significant, because that means that there's a huge amount of population who's going to be buying their first vehicle. Now, if we continue in the trajectory which we are, which means that probably the entire export bill, or the entire import bill of the country on fuel will surpass probably every other export possible, and probably multiple times more. So I think in a very blessing in disguise sort of a thing, that while the industry is growing strong, there is very high incentive for us, not just from a perspective of like air pollution and clean air and all of that, but very purely from an economics perspective, that we need to reduce our fuel import bill, and EVs in that perspective give us a very high opportunity to get that done. Like even if just the basic math on the if you import a certain kilowatt hour of energy in terms of oil, you can only use 25% of that to actually drive you, because that's what the fuel efficiency of your petrol engine is, petrol, diesel, whatever it is. But on the other hand, electric vehicles are almost 85-90% efficient based on which category you're using it. So just by that, the amount of energy used for transportation just comes down significantly, and the energy is a lot cheaper to build to generate as well. So forget about saving the planet, but if you just purely from an economics perspective, there is a very high incentive for us to make this transition from number 3 to number 2 to number 1 in automotive industry on the back of e-mobility. Thankfully, I think we have, even though, and the signs are already there. Like if you see, like about 18 months back, the share of electric vehicles in two-wheeler segment was probably like insignificant, like it's 0.001% or something of that sort. Right? Like you couldn't really make any sense out of it. it's just 18 months or so right now, and we are at a place where we are already at like 4.5 to 5%, and in between we had actually reached 10%. When the fuel prices had reached the peak, the sales were almost 10 to 12% of all the two-wheelers were electric. So means that there is already and almost every single person who's buying a two-wheeler today is definitely considering to buy an electric vehicle. We are seeing similar trends in four-wheeler as well, but four-wheeler, at least the cost difference between a petrol or diesel to a four-wheeler and a electric four-wheeler is quite a lot. But at least in two-wheelers, that's not really the case. The price difference is pretty much insignificant. And we can see in the three-wheeler segment, it's almost becoming on par, and almost 50 to 60% of all the sales of three-wheeler is now electric. So we are already, at least in three-wheeler segment, we are already past the tipping point. In two-wheeler, we are very much near the tipping point where soon enough every other vehicle being sold will be electric, and again and the entire ecosystem has to start becoming ready for it, from semiconductor manufacturers to grid. To just the housing societies, how do you become comfortable with having electric vehicles in your parking lot, and obviously consumers' behavior itself. So we have as the title really mentions, that we are on an electric highway right now, and we're going to see a huge uptake of electric vehicles in the very near future as well, and all of us have to be prepared to respond to that sort of a world, which will be not too far.
Thank you. Thanks, Swapnil. And good to know that for break-even has reached for three-wheeler and two-wheelers going, and probably four-wheeler would become a cheaper deal than the combustion engine. Thanks. Okay, so let me move towards my left with Mr. Brahmanand Patil, because we have seen the views of OEM tier ones. So you being at the core of this software, and we were talking about many software integration in automotive. So please share your views, how you foresee this whole journey.
Sure, definitely. I think as you heard about the market and how the growth is going to happen, that's very clear. And I'm coming from a company which develops embedded software, tool chain required to develop the automotive software. So every OEM, tier one, and the suppliers of automotive use our tool chain, our embedded software component to build further applications on their ECUs. So we are very small, not visible on the vehicle. We are not branded. We are inside each vehicle. That's how I can describe at Vector what we do. But what I see from Vector also is beyond the market predictions, the things that are happening in India. So back in days, later 2010 or 11, there were companies, few companies, named them Bosch, Continental, sitting here in India because they felt they need more number of engineers to develop software for automotive, right? So we are talking of those days, and of course we had our own local Indian OEMs, two-wheeler OEMs, making two-wheelers with joint collaborations with foreign companies. Now fast forward that to today. These companies have grown significant, the global companies, the MNCs. Many more MNCs are setting up their engineering centers in India, not because of cost advantage, because there is talent here. There is a plethora of talent in terms of semiconductors, in terms of IT knowledge, and in between this lies the core automotive embedded software knowledge that is required to develop this huge number of ECUs, the software that is running across the world, not just in India. Now, significantly within the local ecosystem, what we have noticed at Vector, we are talking a lot more to Indian tier ones, Indian OEMs now. Very unique, we are also going back and presenting to our headquarters, like what is India looking at? It's not just the vehicle segment, it's also inside the vehicle. The technology that India is looking at bringing is going to be very significant. This is definitely not going to be a follower of the West. Some of the OEMs, that the work they are doing today, which you will see possibly in the next 2 years, 3 years also in the market, and also we have here Ather, what they have done already in the two-wheeler segment. They have redefined the concept of EV in a way, if I look at it from a consumer point of view. But if you look inside, we have the right ingredients in India. And it's a huge opportunity for engineers in India, not just to look up back to the West. Of course, we bring a lot of work from there. We work for the West, Europe or US and also Japan. But look at collaborating inside India and really making a leapway significant in terms of bringing that disruption. And the West is curious about India, not just as a market for having a lot of engineers to develop their technology, but also as a consumer for their technologies. And this is where we will see huge development happening at the West, looking at the Indian market, and the innovations that India brings are significant. So I have seen this at the development level, working with engineers in companies. The market data, the predictions will always be proven wrong when it comes to India. And to top it up, like you heard as well, the GDP growth, the India economic growth is always there, but also what is happening at the crux in the core processor, in the CPU, is really this, which is happening very quietly in India, where there are no predictions working. These are happening at every company, at every sector as well. And all we need is to just come together and work on these technologies and really look at breaking this barrier. Going ahead.
Thank you. Thanks, Mr. Brahmanand Patil, sharing your view. And I agree. I was with one of our visitors from Netherlands yesterday, and he asked me this curious question that, when India got freedom from the previous rule, and I said it's just 75 years back, and he said just 75 years and you're grown massive. I don't know what would happen in next 75 years. Probably you are going to rule rest of the globe. So that's the perception we Indians are creating with all this advancement. So let me move to my extreme left with Mr. Nitin Gupta to share his perspective, working inside the chip or in general on the EV front.
Thanks, Preet. So let me start with why we need e-mobility or alternative fuels. So I did some studies. So this is like transport sector in India accounts for nearly 20% of energy consumption, which translates to nearly 100 millions of crude oil equivalent. So as Pulkit said, this is the right time to invest, diversify this need, because we are heavily dependent. This demand is met by mainly imported crude oil, which makes this sector more volatile to crude oil pricing. Other thing is, anyway, CO2 emission is another challenge with this. And so I think e-mobility can provide a viable alternative to meet these all challenges. And also, but obviously, this will help in India's rapid economic growth, as well as urbanization, electric needs, and everything. But at the same time, I feel India e-mobility, e-vehicle industry is not at par to the world, and we are still far behind. Although there were rapid growth in two-wheeler sales, electric two-wheeler sales, nearly 300% in last year. But especially cars, we are few thousands of electric cars on the road. And even e-scooters also is less than 1 million on road. While we are heavily, like Indian roads are heavily by, because most of the EVs today has MPRM of 1 kilometer per minute with moderate charger and 5 kilometer per minute with fast charger. While the conventional vehicle
platforms, but beyond that there is cloud. So it's not just a connected car, it's a connected car which is also running the algorithms in the cloud wherever possible, right? You have to judiciously decide what algorithm can run in the cloud because the computing capability required is very high, but then I can get the data, use it in the car. What data can I use down below from the car and make it available for the apps? So OEMs are creating these. There are Linux running, there is QNX, there is Android, right? So there is hypervisor running. You've heard of it in infotainment, but bringing this across the controls in the vehicle. You heard about zonals and so on. So there is no boundary. It's not just about infotainment or HMI. It's about controlling every feature of the car. So talk about the same, reverse assist function. I can build an app on top of it. Any app developer, not necessarily OEM, can build an app. OEM exposes, so the app could be Android-based or, could be Linux-based. The OEM supports, gives a platform for apps for app developers, which are either very open interfaces or maybe a bit specific for the OEM because they are concerned about cybersecurity. The app developer can develop a completely new app saying, let me use a rear camera. As the driver, when I'm approaching the car, it does facial recognition, unlocks the car. As simple as that. No need of changing the hardware, no need of going for another SOP. So these are the capabilities that OEMs are looking at bringing up with the software-defined vehicle. With EV, what is happening is this is speeding up fast because in EV, they have to build every issue. In conventional powertrain, there's legacy which is still lying. They're not touching them. They don't want to touch that. But then they are developing, HMI or, nice infotainment on top of it. But EV is grounds up development. This is happening. You will see apps getting developed for vehicles in the future by an app developer sitting out there. And the concept of software factory is getting rolled out. We are hearing from several global OEMs, but you will also soon hear from an Indian OEM coming in the future, in a matter of 2 years. There will be a platform for app development for an app developer out there.
Just a very short add-on to that. So, I have been hearing about trends about opening up. So, my question is whether this opening up is only partial open platform limited to the infotainment, or will it also give hooks to major control like engine control, BCM, so that innovation, suppose as of today, right, if you change the mode, right, from speed mode to sports mode to highway mode, they're all OEM driven things, right? And OEMs are going to charge, whereas Tesla has already, given such indication that it's going to charge on the fly. As you decide now, you charge, give it now. But innovation means other ecosystem, whether there will be openness in those fundamental controls. So do you see that it's opening only for the infotainment part or for the other fundamental controls of the vehicle also?
So this is it's not about technologically whether it is possible to enable it to open completely or not. It is possible, but the OEMs are judiciously deciding what to open up because there is also cybersecurity threat. We have heard about it. The safety is a critical factor, functional safety. The new feature should not cause any harm to the passenger or the people outside in the car. That's about functional safety, right? It's not just about the safe car, but also the function should not misbehave. So OEMs are putting layers of abstraction and deciding what to open up. It's not just limited to infotainment. There are features like I talked about, having a reverse camera used for beyond purposes, right? Open the boot on its own. We don't need to wait for a new SOP for that. You can enable it. There is Ethernet networking in the car, the IVN. It's no more hardwired CAN or LIN, but Ethernet. So you can always develop these new service-oriented applications. So the service-oriented architecture is already in the automobile. But yes, OEMs are very judiciously deciding what to open up at the moment, considering the safety and security, and what to keep with them, because they also need to enhance these algorithms, what you're talking about, improving efficiency, improving safety, performances of the car, and giving these advantages to the existing users of the car. So OEMs are deciding to do the software update over the air, like what Swapnil mentioned. Hill hold function could be implemented by any developer out there if he structures and gives the app to the user. But then that is such a safety critical function, so the OEM has concerns about opening up to the users.
If I may just add to that, I said earlier, the entire foundation of the software-defined vehicle is based on one thing that he touched upon. We have not spoken in detail today on this, but it is on ensuring we have a super cybersecurity. We had a wake-up call, I would say, a few years back, where some benign hackers hacked into a Chrysler Jeep from their demo lab. And they entered the car through infotainment channel because everything in the car was open in the early days where there was no domain-based architecture and every domain controller was open to the outside world. So they entered the car through an infotainment AM/FM radio, and then they got control over your brakes, your steering, and potentially you can kill someone. Forget about having on-the-air update with advanced features. So until each ecosystem player from semiconductor vendor to a tier 1 to OEM have a same philosophy to block everything else other than one central domain controller which decides with the multiple security layers. I don't think all this thing can fall if we are having a gap into this area. So we believe, again from my prior experience and also what we are doing now, that the entire foundation is going to be safety and security. Safety again, functional safety, but again it's a different detailed topic in itself. But these are the two foundations on which the entire pillar is going to be standing.
So my question is just on that topic which you just last touched upon, which is safety and security. While there were a lot of talk about range anxiety, combating range anxiety and bringing in good other features, especially for two-wheelers, right? Navigation in two-wheelers and so on. So how is an electric two-wheeler more safe or secure than a conventional two-wheeler? So how, maybe I would give it to Swapnil. Yeah. Okay, so how would you convince a common customer that if you take a conventional two-wheeler, it breaks down somewhere, I can go to a local mechanic. If I buy an electric two-wheeler and it breaks down, okay, how can I, of course I can call support, but how is it safer to buy electric two-wheeler?
I think the thing is, like, when you don't have safety net, then you usually define or design things more robustly, right? Like if you look at an airplane versus a car versus an auto rickshaw, right? Like the more risk there is, people end up designing it for a higher level of safety net. Yes, I think we don't have to debate about this. It is very obvious. It's a more complex piece. An electric vehicle is a lot more complex piece than a gasoline vehicle. And yes, I mean, like, honestly, life was much simpler when we were in monkeys, like on the trees, right? Life, yes, becomes complex, and we have to start designing solutions, understanding the risks, right? Like every single thing, keeping money at home was better than like keeping it in bank where it can be hacked and lost. So as we introduce solutions which becomes which makes our life better, it also comes with its own set of risks. And but what ends up also happening is that you start understanding those risks and mitigating for the same. An electric vehicle, as I said, is a lot more complex, which means that we have to build a stronger, firstly, a vehicle which does not break down itself. That becomes a priority for us. Second, if it breaks down, how do you ensure that a quick roadside assistance is available for the customer to be able to like give a quick solution for them. Similarly, as we evolve, the vehicle, again, like, the equivalent of a roadside mechanic and even the roadside mechanic will start learning the skills which is required to fix an electric vehicle, and as OEMs we'll start making things a lot more simpler for the roadside mechanic to fix things as well. So I think it's an evolution. I wouldn't say that on day one, okay, this vehicle is as serviceable by a roadside mechanic as a petrol vehicle is. But what we have definitely tried doing is that make it very, very reliable, so that you don't really have to go to a roadside mechanic except like fixing a puncture or something. So I think both ways it will happen. We will keep making the vehicle more and more reliable, lesser moving parts, which essentially means that the probability of failure is lesser. But at the same time, learning from the existing vehicles, how they made the vehicles a lot more serviceable even for a roadside mechanic. I think we will have to, the journey is not done. We have to learn a lot from the established industries and start making those modifications in a vehicle to make it more serviceable.
One question I'd like to add there.
This is going to be the last question. I already see a lot many raised hand. Few of us has to catch up a flight, okay, and we still don't have autonomous vehicle who can run faster. Okay, so this let it be the last question which you have on mind.
Yeah, so I was just going to ask about battery state of charge and heating conditions, which, I mean, you've all heard of the stories where a two-wheeler EV blew up. Okay, so I think that there is some amount of skepticism amongst the buyers as well, that there is a risk there. So how would you confront that?
Yeah, it's a lot about design, right? Like if you take shortcut, I mean, like we have heard about petrol vehicles also catching fire. So how do you really, just to give you an example, what we do, right? Like ensuring very high level of accuracy on your voltage measurements. Having multiple level of redundancy on safety so that the vehicle or the battery doesn't get overcharged, doesn't get overheated. Having a good thermal management system which ensures that the battery never gets heated up irrespective of whatever is the usage condition. A thought through design is very critical with multiple level of redundancy on parameters which impact the safety of the battery of the vehicle. Is the only way to go forward for designing a safer vehicle. Batteries are risky, but well, petrol is a lot more risky than batteries. But we learned how to design good vehicles, petrol vehicles, and we don't take shortcut. If we take shortcut, even the petrol vehicles will catch fire. So I think that's going to be important. What happened is that the momentum of building electric vehicles, like everyone just thought that, okay, what's there to build an electric vehicle? Just connect some batteries together, put some motor, and then give it. And anyone can do it, right? Like everyone thought that anyone across the country can actually just build an electric vehicle. But they forgot about the safety. They forgot about all the complexities which come with handling a battery, and then which led to some of these incidents. I think again, taking a learning from it, and with more stringent now regulations on battery safety which have come up for automobiles, I think batteries will be safer than petrol vehicles. It will be much more fast forwarded than what it has been in the past.
Thank you.
Okay, so I would request let it be the hard stop because few of the panelists have a flight to catch up and rest of us would be available for rest of the evening until for the banquet dinner. So quick summary, Sanjay mentioned about, collaboration amongst Indian-based partners, ultimately as Swapnil also mentioned that innovation need not to happen. It can happen in any corner of the world. But if we can, make it a more, I would say, indigenous in terms of production. And Swapnil's point, to how do we cut oil imports? How do we make things more efficient? How to get, more out of whatever we have in our pockets? And Brahmanand bring up the topic, how software can closely work directly with, the OEMs and tier ones rather than breaking the traditional loop, instead of sitting on hierarchy, it's like it used to be either upside down or, so instead of upside down, it should be the both way around. And finally, Nitin brought up the point of, the EV infrastructure, how we can, work to have a global EV, setup to be available because that will enable the vehicles for tomorrow. So let me just summarize, we started with some numbers. China took over as a global leader from Japan in 2006, and they surpasses US in 2009, and last 16 years, they are the, number one for the whole automotive market. And we just, assuming, another 2 weeks we'll have results that India would become the third largest, but the future would define that how do we become from third largest to second largest and the largest, but after you become the largest, how do you hold that position for the next coming decades, etc. So thank you so much for all the great leaders to show up today for the interesting deliberations here. I would now request a few of our industry partners and their senior members to help and pass on a memento of thanks to our panel members. So let me start with Mr. Thanks, Rakesh. Thank you, Sanjay. Now let me request Mr. Satish, again from the organizing team of VLSI. Okay, can I request Mr. Ritesh to come and facilitate Mr. Brahmanand from Vector?
Mr. Sanjay to present a memento to Preet for moderating such a wonderful request all the delegates post this session. We have all three. We have address from Mr. Thomas Lee from Stanford University, and former Defense Minister also will be addressing. And also we have awards night followed by a banquet dinner. Request all the delegates to stay back till the event is over.